Good afternoon to all participants of our workshop. The theme of our research is Informational Technology and Mathematical Modeling for Environmental Safety. Now let's speak some words about the problem. The level of danger of the man-made features to the environment and population health can be differentiated from the most insignificant to critical and even catastrophic. The level itself is quite uncertain and it is linked with the primary ecological state of the environment. Therefore, it is very important to create a system of environmental safety which would monitor the change in ecosystems and manage the forecasting. For problem solving, it is proposed to use the method monitoring data-based forecasting using situational and inductive models. In general, the approach contains a number of following steps. A situational model is a model adapted to a certain situation or forecast background. Model is valid only for specific context. The forecast background is characterized as a set of external and internal conditions essential for the choice of structure and model parameters. Situational models are built on the basis of series of actual monitoring data and reflect the individual phase states of the associated dynamic system at different time intervals. In this case, the transition from one situational model to another, which determines the neighboring phase states of a dynamic system, can occur abruptly. The results of situational modeling form the basis for the subsequent construction of inductive models, where the inductive model is a model obtained from the generalization of several situational models, and inductive model based on series of model data. It contains the result of situational modeling actual data statistical processing. Also, it can cover several heterogeneous clusters of relevant data and reflect the comprehensive dynamics of model values of the resulting variable over time. Forecasting has to be based on short-term situational models, which monitor the endogenous variable model dynamics within time intervals with valid situational models. Also, it can be developed on the basis of level inductive models for monitoring of situational models dynamics as past states, phase portraits of a dynamic system. Sequential models can be established to determine the dependent variable for future periods. In such problem setting as communication equations, in the construction of situational and inductive models can be used simple dependencies. May be easily adapted to new datasets and changes in the predictive in the time series background. Let's speak about regression and correlation analysis. The research of the relations between indicators of environmental pollution and the pollution health is one of the main in the area of environmental safety. Informational value and the obviousness of the analysis results are submitted by quantitative characteristics. Their further use in decision making can give a number of opportunities. Associating between the measured values of the state of the ecological situation, and health indicators in dynamics that can be represented and a functional dependence. Number one, you can see it on the screen, where E is deviate from the ambiguously defined function that is not associated with the influence of environmental factors and measurement error. The definition in one is regression dependence, and the function z is a regression function from SAS. We will consider a variable is independent and a variable as a dependent. The task of correlation and regression analysis is to establish the fact of the connection between Z and SAS, with finding describing the relation function. The functional dependence can be used to predict the values of the dependent variable in the range of values not studied in detail, if statistically significant relationships are found between the researched data and the dependent variable can be expressed with a slight deviation as an analytical function from the independent one. Forecasting will contain some inaccuracy, which depends on the accuracy of the approximation, the volume of the deviate, and the interval for founded analytical relationship. The analytical function may not be the same in different ranges of values of the change of the independent variable. It belongs to the approximation of piecewise continuous dependencies. Regarding the population morbidity, level change of risk factor in the interval between the threshold values belongs to change in health indicators. In the area below the sensitivity threshold and above the saturation threshold not observed. These thresholds may be different for different health indicators. Now let's formalize the task of analyzing the ecological situation of a certain area and its impact on health. We introduce the concentrations and types of diseases labeling for the research of the chemical elements' concentration characteristics. Concentrations of pollutants in soils and surface waters of ecological sites are described as KZ, where I varies from 1 to 17 according to the numbers of ecological sites, districts of Ternopil region in Figure 1. Figure 1 shows you the map of ecological sections in Ternopil region. J varies from 1 to 9 according to chemical elements, as plumbum, zincum, cadmium, calcium, manganese, magnesium, cuprum, and nickel. These variables in Formula 1 define SES. They describe the environmental situation and are independent variables. In mathematical modeling, they are sometimes called independent argumentative factors, exogenous, predicative, or explanatory. Variables that describe the impact of their environment, namely the morbidity or mortality of the inhabitants of a certain area, will be marked using the International Statistical Diseases, Injuries, and Death Causes classification. They will be marked by such means as 1. Diseases of the blood and blood-forming organs, 2. Respiratory diseases, including 3. Chronic bronchitis, 4. Bronchial asthma, 5. Diseases of the digestive system, and 6. Oncological diseases. The prevalence of diseases was marked as the X. Index I specifies the number of the ecological site varies from 1 to 17, and J the number of the type of disease. Another type of variables that are not directly measured reflects the impact of income level, level of health care, heredity, and measurement errors. Now we can formulate the task of analyzing the data of the ecological situation of the territory and medical care. It is necessary to construct the following vector function on equation 2. Equation 2 can be used to calculate the values of the output variables depending on the environmental characteristics. The fact function must be found by mathematical methods, for example by the method of least squares. To solve this problem, it is necessary to begin by finding out the existence or absence of a statistically significant relationship between variables. Right analytical dependence should be found only if such a connection exists. In equation 3, the variable corresponds to one of the columns of the matrices for a fixed value of j, namely one of the types of morbidity or mortality, and the variable number second relates to one of 7, to one of a given set of chemical elements concentrations. For a normal distribution of random variables, the correlation index is converted into a correlation coefficient on equation 4. The value of the correlation coefficient of a sample as statistical estimate of the unknown R value was calculated from known data pairs of input and output variables. Each of the calculated correlation coefficients should be tested for the significance of the statistical supposition as 0. Therefore, it should be tested to the supposition of no correlation between the studied variables. Now let's use the characteristics of the student distribution. You can see it on equation 7. The range of application is determined by confidence intervals for the true value of the correlation coefficient, which are constructed based on the normality of the distribution. The segments are calculated as you can see on equation 8. After research the nonlinear dependence of random variables, we can make the conclusion that the correlation coefficient is not considered to be the main characteristic of the closeness of the connection. Using datasets, we should use a calculation using the equation 2 of the correlation index. First, it is necessary to specify the type of functional dependence. Now, select a dependency 9. And in this case, the correlation evaluation index will be made using equation 10. The strength of the relationship between several random variables can be determined by a multiple correlation coefficient. For random variables and multidimensional quantity, it is determined by the equation number 11. If the distributions of the random variables S and Z cannot be considered as normal, we use non-parametric statistical methods, such as the method of rank correlations. It is based on the Spearman or Kendall coefficient. In the case when the samples do not have the same values, Spearman's rank correlation coefficient is calculated using the equation number 13. The multiple statistical relationship between several ordinary variables shows the concordance coefficient, which is calculated using the equation number 16. Let's speak some words about variance analysis. Analysis of variance is used in the task of health risk if the risk factors are registered in ordinal or qualitative scales, and health indicators are registered in quantitative terms. The principle of method is to divide the sum of squares of deviations of the dependent variable from its average into several components associated with different sources of variability, such as the action of individual risk factors, their interactions, as well as residual sum of squares. Then the sums of squares corresponding to the factors are compared with the residual sum of the squares. The supposition is lie in the fact that factor does not affect the dependent variable is rejected if the sum of squares belong to this factor is significantly greater than the residual sum of squares. In this case, the method of analysis of variance is similar to regression. In variance analysis, the terminology used is slightly different than in other sections of statistics. Independent variables are called factors, their values are called factor levels, and dependent variables are called response variables. Single factor analysis of variance is used when it is necessary to assess the influence of a single factor of the response variable. Response variables are expressed in equation 17. As the null hypothesis in the single factor analysis of variance, the proposal of equality of the average response variables for all levels of the factor is considered. An alternative is to have at least one pair of levels for which the average values of the response variable are different. If the null hypothesis is correct, then it is necessary to solve the equation number 20. When f is Fisher's distribution with numbers of degrees of freedom, so the critical area at a given level of significance is the range of values exceeding the quantile of the order of Fisher distributions with degrees of freedom. In the previous analysis, each value of the number of patients corresponds to two values of the frequency of diseases, though the degree of influence of the number of the frequency of diseases can be assessed using analysis of variance. Therefore, two-factor analysis of variance, taking into account the interaction of factors, allowed to identify significant differences in average levels of morbidity in different areas, which are also detected by factor analysis, and the presence of pronounced dynamics of morbidity, which is not detected by one-way analysis. Firstly, it is not the same for all areas, and secondly, is characterized by difference in average levels of morbidity by territory. The next approach to solve that problem is category data analysis. This method of relationship analysis is used when both independent risk factors and dependent variables, for example, health indicators, are ordinal, qualitative, or quantitative, expressed not in absolute values but divided into a small number of categories. Categorized data are presented in the form of observation frequencies corresponding to different categories of the studied indicators. The initial data for the analysis of the relationship between two variables A and B are presented in the form of so-called conjugation tables. Let the number of gradations of factor A be 1i, and the number of gradations of factor B be equal to j. If the null hypothesis about the independence of factors A and B is implemented, then we will have statistics in dependency 21. The above data can be used to determine whether there is a relationship between environmental pollution and public health. Comprehensive indicators of both ecological and medical demographic condition of the territory were calculated for the territories of Ternopil region. To assess the dynamics of ecosystem in Ternopil's region, a GEO database was developed. GEO database includes a set of space images from Landsat 7 and Landsat 8 satellites, topographic maps, detailed digital terrain models. Space images with a resolution of 5 meters were used for the analysis of the environmental situation and anthropogenization of the researched ecosystems. 1000 scale map, fragments of afforestation plans, cartographic data of landscape ecological researches were also used during this research. Now we will present some conclusions. Based on the calculations, the territory was ranked according to the system of rating assessments both for individual indicators and for the integrated indicator. According to the integrated indicators, it is possible to assess the severity of risk factors that justify the priority of environmental measures to improve the living conditions of the population. They are classified according to the following gradations. First, favorable situation. Life expectancy persists and increases, the morbidity rate decreases. Second, zone of tense ecological situation, the area within which the transition of the environment from crisis to critical is observed, medical and demographic problems are increasing. 3. Zone of critical situation, the impact of environmental pollution on humans is recorded in all known statistical indicators in the field of ecology and medicine. 4. Zone of ecological emergency. Living conditions are deteriorating so much that voluntary resettlement is desirable. And fifth is a zone of ecological disaster. Thank you for your attention.